Good day, students. Welcome to Earth and Life Science Remediation Program. Currently, you are on Week 1, Lesson 5 of this program. Today, you will be able to describe how rocks behave under different types of stress, such as compression, pulling apart, and shearing, and explain how the movement of plates leads to the formation of folds and faults. Before we begin, may we remind you to take photos of yourself while watching this video and while taking notes. Your photo collage will serve as your attendance for today. Now, let's begin. In our previous discussion, you were able to describe where the Earth's internal heat comes from and describe the changes in mineral components and texture of rocks due to changes in pressure and temperature or metamorphism. Before we go to the discussion, let's try to do this drill. This activity is called odd one out. You have to identify the word or picture that does not belong to the group based on the category given. You have 10 seconds to answer each item. For example, the category is fruit. Here are the pictures. Which one is the odd one? That's right. The celery is the odd one out since it does not belong to the fruit category. It is a vegetable. I think you're now ready for the first item. The category is sources of the Earth's internal heat. We have heat from the sun, primordial heat, radioactive heat. Which of the three is the odd one? Time's up. The odd one is heat from the sun. The next one is types of metamorphism. We have regional metamorphism, contact metamorphism, magnetic metamorphism. Which one is the odd one? Time is up. The odd one is magnetic metamorphism. Next category is agents of metamorphism. We have heat, solar flare, pressure. The odd one is solar flare. The next category is types of heat transfer. We have induction, convection, radiation. Which one is the odd one? Time is up. The odd one out is induction. Next category is foliated metamorphic rock. Which one is the odd one? The odd one out is the third picture. Now let's go to our discussion. If you're going to use the Google Earth and type these places, you will see spectacular geologic features. Observe the following geologic features. What do you observe? Anong napapansin niyo sa picture na to? How about the next one? and this one. What do you think caused these deformations in rocks? Mapapansin natin na may mga deformation, cracks, sa surface ng Earth. Ano kayang nag-cause ng deformation na ito? The answer to that question is stress. Stress are forces that deform rocks. May dalawang klase ng stress, confining stress at differential stress. Ang confining stress ay may pressure in all of its sides. The pressure is applied in all directions. Sa differential stress, unequal ang application ng force. At meron itong tatlong types. We have compressional stress, tensional stress, and shear stress. Ang three types na ito ang pag-uusapan natin sa araw na ito. Unahin na natin ang compressional stress. Ang compressional stress ay nag-i-squeeze sa rock. Dahil sa pag-squeeze niya sa rock, nakaka-form siya ng folds and reverse fault. Tingnan natin itong figure na to. So una, straight pa yung rock mass. Pero nung na-applyan ng force sa magkabilang side, nagkaroon siya ng compressional stress. Na-squeeze itong rock mass na ito at naka-form siya ng folds. Aside from that, pwede rin siyang maka-form ng fault na tinatawag natin na reverse fault. Sa compressional stress, from the word itself, nako-compress yung rock mass. At dahil doon, nakaka-form siya ng folds. At merong dalawang parts ang folds. Tinatawag natin na anticline at syncline. Ang tawag sa pataas na fold or upfold ay anticline. Ang tawag naman natin sa pababang fold or downfold ay syncline. Nagkaroon ng anticline at syncline dahil sa compressional stress. Kanina sa picture, tinignan natin through Google Earth na itong rock mass na to ay na-compress. Kaya nagkaroon siya ng anticline, pataas na fold, at nagkaroon din siya ng syncline, pababang fold. Aside from anticline and syncline, nakaka-form din ng reverse fault ang compressional stress. Mapapansin natin, pag sinabi nating reverse fault, yung hanging wall ay umaangat with respect to the foot wall. Ano nga ba ang hanging wall at foot wall? Para malaman mo na ito ay foot wall, mapapansin mo na ang shape niya ay parang shoe or paa. Kaya siya tinawag na foot wall. And this piece of rock is the one that moves. Kaya siya tinawag na hanging wall. Kapag nagkaroon ng compressional stress, umaangat ang hanging wall with respect to the foot wall. Ang tawag natin sa fault na yan ay reverse fault. The next type of stress is the tensional stress. Tensional stress stretches the rocks. Dahil sa pag-stretch niya sa rock, nakaka-form siya ng normal fault. Mapapansin natin dito sa figure, merong dalawang forces na nag-a-act dito sa piece of land. Pero itong dalawang forces na to ay, ang direction ay away from each other. That's why that piece of land is being stretched and it becomes thinner at the center. Later on, aside from stretching and thinning, pwede rin siyang maka-form ng normal fault. Ano nga ba ang normal fault? Pag sinabi natin normal fault, ang hanging wall ay bumababa naman relative or with respect to the foot wall. Matatandaan natin kanina sa reverse fault, paangat ang hanging wall. Pero dito, dahil sa tensional stress, ang hanging wall naman ay bababa. When tensional stress pull crust apart, it breaks into blocks that slide up and down along normal faults. The result is alternating mountains and valleys known as basin and range. Tinatawag din siya na horst and graben. Ibig sabihin, dahil sa tensional stress, pwedeng magkaroon ng sunod-sunod na valleys and mountains or horst and graben. Dito sa figure na to makikita natin na maraming normal fault. Dahil sa pagkakaroon ng magkakasunod na normal fault, nagkaroon din ng magkakasunod na valleys and mountains. Itong pababa na piece of land ay tinatawag na valley or graben. Ito namang nakaangat ay tinatawag na horst or yung mountain. Another type of differential stress is the shear stress. Shear stress fractures rocks and moves one body of rock past another. This also forms strike-slip fault. Dito sa figure, makikita natin ang direction ng dalawang forces. One is going backwards and the other one is going forward. This causes shearing and therefore it can form a strike-slip fault. A fault in which the dominant displacement is horizontal and parallel to the trend of the fault surface is called a strike-slip fault. Isang example ng strike-slip fault ay ang San Andreas Fault na makikita sa California, USA. Therefore, we have three types of differential stress. We have compressional stress, which squeezes rocks and forms folds in reverse fault. We have tensional stress that stretches rocks and forms normal fault. And lastly, we have shear stress, which fractures rocks and moves one body of rock past another and forms strike-slip fault. Where do the types of geologic stress come from? Saan nanggagaling itong mga stress na ito? Rocks can deform due to the forces of plate tectonics. Plate tectonics is the theory that the Earth's lithosphere is divided into tectonic plates that move around on top of the asthenosphere. Ikumpara natin ang dalawang picture na ito. Ano ang pagkakapareho nila? Katulad ng cracked egg sa kaliwa, ang Earth din ay hindi buo kundi may mga crack ito sa lithosphere. Ang bawat piraso na ito ay tinatawag natin na plates. Plates or tectonic plates are gigantic pieces of the Earth's crust and upper mantle o tinatawag natin na lithosphere. Kung tatanggalin ng tubig sa Earth, ganito ang magiging itsura niya. What do you observe? Hindi siya smooth, may folds, cracks, and scarps. Ito ang isa sa mga nagpapakita na ang lithosphere ng Earth ay binubuo ng plates. Plates na patuloy na gumagalaw dahil sa convection sa ilalim nito na nagiging cause ng folds, cracks, and scarps ng Earth. Balikan natin ang parts ng interior ng Earth. Makikita natin dito na ang lithosphere ay binubuo ng crust and upper mantle na rigid at sa ilalim nito ay asthenosphere. Itong asthenosphere ay plastic-like. Okay. At merong convection na nangyayari sa asthenosphere. Dahil sa convection na nangyayari sa asthenosphere kung saan umaangat ang hot molten rocks at bababa naman ang mas malamig na molten rocks, nagkakaroon din ng paggalaw ng plates. All tectonic plates have boundaries with other tectonic plates. These boundaries are divided into three main types, depending on how the tectonic plates move relative to one another. And these are transform fault, convergent, and divergent plate boundaries. Plate boundaries are found at the edge of the lithospheric plates. The first type is convergent boundary. It's the boundary where the two colliding plates meet. Ang dapat nating tandaan sa convergent boundary is that the two plates move toward each other. Merong tatlong type ng plate boundaries. We have the ocean-to-ocean subduction or ocean-to-ocean convergence. We have continent-to-ocean convergence. And we have continent-to-continent convergence. Pag-usapan natin ang bawat type ng convergent boundary. The first one is continental plate to oceanic plate. Kapag nagbanggaan ang continental plate at oceanic plate, ang oceanic plate ay o magsasabdak. At tinatawag natin ito na subduction zone. Ito yung zone o lugar kung saan lumulubog o bumababa ang oceanic plates. At ang nagsabdak na oceanic plate ay matutunaw sa part na ito ng mantle at possible na maging magma at yun ay aangat sa continental plate. Ang continental plate naman ay magkakaroon ng folds or mountains at dahil meron siyang magma sa ilalim, instead of just being a mountain, ay makaka-form siya ng volcano. So, in continental plate to oceanic plate convergence, magkakaroon ng volcanic arc dito sa ating continental plate. A good example of that is the Andes Mountains found in South America. Makikita natin na yung Nazca Plate at South American Plate ay nagkaroon ng convergence o collision. They move towards each other. Yung Nazca Plate, which is an oceanic plate, ay bumaba o nagsabdak. At ang South American Plate na continental plate ay nagkaroon ng folds or mountains. Ang bumabang part ng Nazca Plate ay naging part ng mantle at naging molten rocks. This can cause magma to be formed and rise up in these formed mountains. And these mountains can become volcanoes. At kapag magkakatabi o sunod-sunod ang mga volcanoes, we call that a volcanic arc. Another type of convergent boundary is the oceanic to oceanic convergent boundary. Nangyayari naman ito kapag two oceanic plates ang nag-collide. Anong mangyayari kapag pareho silang oceanic plates? So kapag pareho silang oceanic plates na nagbanggaan, yung isa sa mga oceanic plates naman ang magsasabdak o magi-slide under the other. Anong mangyayari? Anong pwedeng mangyari kapag ang isa ay nagsabdak? Kapag ang isang oceanic plate ay nagsabdak, yon ay magiging part ulit ng mantle at matutunaw. And this can form magma. On the other oceanic plate, pwedeng makaform ng fold at dahil may magma sa ilalim, it can become a volcano. So this is the reason why there are volcanoes even in the ocean. So subduction of an ocean plate beneath other oceanic crust results in a volcanic island arc and an ocean trench like Marianas Trench. Makikita natin dito na even though it's in the ocean, meron pa ring mga na-form na volcanoes. At these form volcanoes na magkakatabi ay tinatawag natin na volcanic island arc. Katabi naman ng volcanic island arc ay nandoon ang trench. Yung trench ay nabuo dahil sa subduction zone. Dito sa part ng trench lumulubog yung isang oceanic plate. Katulad na lang ng Philippine Plate at Pacific Plate, kung saan ang Pacific Plate ay nagsasubduct. Kaya at yung subduction zone na yan, yun yung tinatawag natin na Marianas Trench. At yung mga volcanic island arcs na nabuo, tinatawag naman na Mariana Islands. The last type of convergent boundary is the continental plate to continental plate convergence. This happens when two tectonic plates with continental crust collide. They buckle and thicken, pushing the continental crust upward. Dito naman, dalawang continental plates naman ang nagbabanggaan. Ano kaya mangyayari kapag dalawang continental plates ang magbabanggaan? Mapapansin natin na walang nagsubduct. Ang nangyari ay, pinush lang nila ang isa't isa upwards. So therefore, makaka-form ng mountain range. Isa sa mga halimbawa ng mga mountain ranges na na-form dahil sa continental plate to continental plate convergence ay ang Himalayas. Mapapansin natin sa figure na ang Indian-Australian plate at Eurasian plate ay nag-converge or nag-collide. Pareho silang continental plate at naka-form sila ng folds. Walang nagsubduct, kung hindi, umangat lang sila upwards. Therefore, na-form ang Himalayas. The next type of plate boundary is the divergent boundary. Dito naman, the boundary where two plates are moving away from one another. Ang direction nila ay papalayo sa isa't isa. Isang magandang halimbawa ng divergent boundary ay ang boundary sa pagitan ng North American plate at ng Eurasian plate. So these two plates are moving away from each other. This map shows the mid-Atlantic ridge splitting Iceland and separating the North American and Eurasian plates. So it means that the divergent boundary can not only be found in the ocean, like the mid-Atlantic ridge, which is found in the Atlantic Ocean. It can also be found on land, which is visible in Iceland. This is a famous geological place to visit. Ang pag-diverge din ng dalawang plates ay nagkukos ng tinatawag natin ng mechanism na seafloor spreading, kung saan ang rising magma ay nagsosolidify at nagiging bagong rocks, habang tinutulak naman ito ang older rocks papunta sa magkabilang side. The last type of plate boundary is the transform boundary. It's the boundary where two plates slide past another. So one is moving forward and one is moving backwards. Because tectonic plates are not smooth, they grind and jerk as they slide. People who live in Southern California can feel these frequent jerks. They call them earthquakes. So transform boundary can cause earthquakes. The San Andreas Fault is a sliding boundary between the Pacific Plate and the North American Plate. This is a picture of the San Andreas Fault found in California, USA. These two plates here are sliding past another. It's now time to do some activity. Let's do activity number 1, which is titled, What Deformed Me? All you have to do is to identify the type of geologic stress, which are compression, tension, or shear, that deformed the following geologic features. So, ang pagpipilian nyo lang ay compression, tension, or shear. Let's try the first one. What deformed this geologic feature? Is it compression, tension, or shear? Number 2. What deformed this geologic feature? How about this one? Number 4. And number 5. Now let's check your answers. Number 1 is deformed by compression. Makikita natin na may anticline at syncline. So merong folds. It's due to the compressional stress or compression. Number 2 is caused by tension because this is a horst engraving and it also formed the normal fault. Number 3 is compression because this is a reverse fault. Number 4 is caused by tension, stress. And number 5 is caused by shear stress. How many correct answers did you get? I hope you were able to get all of these correctly. Now let's go to our activity number 2, which is titled Matchy Matchy. All you have to do is to match the terms in column 2 and 3 with the given terms in column 1. So in column 1, we have the types of plate boundary: convergent, divergent, and transform. In column 2, these are the movement, but these are not correctly placed. So you have to put these terms in their correct places. Also, the third column is the geologic feature or event associated with it. So you have to put all these terms in their correct places also. For the illustration, you also have to put all these in their correct places. Let's check your answers. So convergent towards each other. The geologic feature or event are mountain ranges, volcanic island arc, and trench. And this is the illustration. For divergent, the movement is away from each other. The geologic feature formed are oceanic ridges and rift valley, and the illustration is this one. For transform, plate boundary, the movement is sliding past each other, and the geologic feature is fault, and the illustration is this one. So I hope you got all of these correctly. Let's now go to the summary of our lesson. Today you learned that there are 3 types of stress on rocks. We have compression, tension, and shear. Compression stress squeezes the rocks and forms anticline, syncline, or folds, and reverse fault. Tension stress stretches the rocks and forms normal fault. Shear stress fractures the rocks and forms strike-slip fault. You also learned that there are 3 types of plate boundaries. We have convergent, divergent, and transform. Plates with convergent boundaries collide. Plates with divergent boundaries move away from each other. Plates with transform boundaries slide past each other. Congratulations! You are now done with Lesson 5. I hope you've learned a lot from our lesson today. See you next time. Bye!